Hello, this is the third video of the Critical Path Analysis Series 2 on cascade charts and scheduling. We will look further at analysing the floats. So far we have considered only the total float for an activity, and we've shown this on the cascade chart. But some or all of the total float may be independent float. This is the flexibility that may be used without checking previous or subsequent activities in the network. The remaining float is called the interfering float, and this part of a float may affect or be affected by the other activities. In other words, it is shared between activities, and so the flexibility it infers may have already been used by a preceding activity or indeed required by subsequent activities. You may remember that we can calculate the float using these rules. So the total float was the latest finish minus the earliest start, take away the duration of the activity. And we got these from the boxes on the activity network. So for example, we had for that activity E was the latest finish time being 18, take away the earliest start time of 4, take away the duration of 13, leaving a total float, say, of 1. Remember that the critical activities have a 0 float. Now the independent float is the earliest finished, take away the latest start, take away the duration. So whereas we had the box and then the activity duration, which was in brackets, so let's just put E and 13 in there as an example, and that would have been 4, and then that was the 18. So whereas for the total float we use the outside boxes, then for the independent float we use the two earliest finish and the latest start, so these two inside boxes minus the duration instead. And then we can deduce that the interfering float is the total float minus the independent float. So looking at this example here for an activity K, the total float would be the 22 minus the 8 minus the 10 equal to 4. The independent vote would be 20 minus 9 minus 10, or 1, and therefore the interfering float will be 4 minus 1 equal to 3. If we were to have an activity network, a cascade chart, and then to compile a table of the floats, note that the critical activities are left out because we know they will all have floats of 0. So considering B, the total float would be 18 minus 0 minus 11 equals 7. The independent float would be 11 minus 0 minus 11, or 0, thus making the interfering float as 7. For D, we would have 26 minus 8 minus 12 to give us 6, and then the independent float would be 26 minus 8 minus 12 equals 6, and thus the interfering float is 0. For F, 26 minus 11 minus 8 equals 7. 26 minus 18 minus 8 equals 0, giving us 7 in the final column. For G, 31 minus 11 minus 5 is 15. 31 minus 18 minus 5 is 8, and therefore an interfering float of 7. And for I, 31 minus 21 minus 8 is 2. 31 minus 21 minus 8 is 2, giving us 0 as an interfering float. Hopefully you can see we've got all the numbers from in the boxes in the network. The total floats, of course, are shown as the dotted lines on the cascade chart. We can see from the activity network and from our previous look at the cascade chart that F and G can only start when B is completed. Thus, if B uses any of its float, F and G are also forced to be rescheduled and in effect use the same amount of their floats. Let's consider this in more detail. If B were to slide along and use some of its float space, then F would have to move by the same amount, and so would G. But you can see that therefore B has no independent float, only what we call the interfering, or in effect shared float. And similarly for F. The only activity which comes after D is J, and you can see here that even if D uses all of its float and finishes at this point, it's not going to affect J, and therefore all of D's float is independent and none of it is interfering. There is a lot of flexibility as to where G can start and finish, as evidenced by the total float of 15. The only other activity that impacts on it is where B finishes. So you can see that even if B was to use all of its float and G was to start here, that G still has quite a lot of independent float, 8 units to be precise, with that 7 of interfering shared with B out of its total of 15. In the next video, we look further at resourcing and scheduling.